And if you open up that don't play with your computer because I lost a few people when we did that last time. But this one says, if fuse A blows, this one opens, what would be the current in the neutral conductor and the voltage across the blown fuse, okay? So right here, fuse A blows. What you got to do on all these neutral, if we blow this line, we blow the neutral, open the neutral, or we open that line, is we got to go back and get resistance using Ohm's law on all these, okay? So having said that, we're going to come back here, and right now, so we're going to pretend that fuse isn't blown. These are the wattages under normal conditions, okay? So right here, I've got 120 volts, 1200 watts. I'm going to have 12 ohms. $12 ohms on that one. I'm going to have 24 ohms. This is 240 volts. And that's 2400 watts, 240 volts. That's going to be 24 ohms. This is 1800 watts. This is going to create, on 120 volts, that's going to give me 15 ohms. Now let me just double check that. I think I got all that right. 8 ohms. I apologize. This one's 8. 8 ohms. So 12 ohms, 8 ohms, and 24 ohms. No matter how much voltage I give that, that'll be true. This changes with voltage. If I lessen the voltage, that goes down exponentially. If I increase the voltage, that goes up exponentially. So now we can erase this. These are useless numbers. Cross them out. They don't mean anything any longer because I'm not giving it the voltage that it had. I'm going to erase this fuse. That's blown. I'm going to want a voltmeter across there eventually, okay? So let's go like right here. So now if we look right here, this doesn't come into play. That's gone. I've got 120 volts right here. And it goes through here. So I'd say nothing changes in this one. Agreed? So that's going to be 120 volts. And that's going to still give me 1800 watts. And that's going to, if that equates out to 15 amps. Okay? That's because it's on the right side of the bus. And the bus is the breaker. So this is on the line 2 bus, and it works beautifully. Now this, however, and this used to have 120, this used to have 240. Now it's got, if we look, this is a series circuit with 120 over the whole mess, right? So 12 and 24 is the total resistance of this branch. So 12 plus 24 is 36 ohms. 36 ohms over 120 volts causes what kind of a current to flow? Current flows here at a rate of 3.3 repeating amps, right? All right, let's look at this. 3.3 goes down through here, you get a voltage drop there, you come into this node. 3.3 comes into that node. 15 right there. So this comes 18.3 repeating amps on line 2. If I've got 18.3 repeating amps and I've got a 2-wire system now coming home, going out there, I gotta have 18.3 repeating amps. We agree? It gets to this node. 15 goes through this. Whatever this is working just fine. These, however, have different voltage drops over them. Okay? Let's go back. We've calculated that out. There's my neutral current. The voltage measured across here. Now what I like to do, and we said yesterday on bridge circuits, any closed loop, right? 120 blah blah will be equal that. I like going back to my 240 when I lose my neutral because you can get a little bit lost in there. Okay? So let's go back here. 3.3 repeating amps multiplied by 24 ohms gives me what kind of a voltage drop over that bad puppy? And if we look over there, I don't know what it is.
It's 79.92.
79.92 volts. I like that. 79.92. If I take my voltmeter right here, guys, and I go like this, I'm going to read 240. I've got a 240 volt rise. A closed loop coming right through here. This voltage drop, the voltage drop over the open fuse has to equal 240 volts. Okay? So let's do that. 240 minus 79.92 will equal what?
160.
160 volts over my blown fuse, right? So that's the way we do it. It also works any way you do it, right? So 120, let's get the voltage drop here. 120, you got to remember that my current is going a different way there. 120, what's 3.3 repeating times 12?
39.96.
So you take 120, now this, again, changed direction because it used to come down. 120 plus 39.96 equals 160, right? It all jives. It all's got to jive all the way through. And I don't care which way we go through here, what we do, that's got to be true. Now this is definitely going to be on the test. We'll go over this in some detail. I'll go over a little harder ones tomorrow. Now I'd like everybody to take a moment. If you haven't done it already, I'd like you to do this. I've got to erase this whole mess and I've got to draw another problem on the board. So we'll take a little break and I'll prep up here, okay? I'm yelling at you.